Welcome to Lesson 1-1. So this is Chapter 1, Lesson 1, Using Estimation Strategies. This lesson is going to take a little bit longer as I'm going to go over how to use your workbook and what I'm looking for in your workbook. And then after this, we should be able to move a little bit more quickly when it comes to these video lessons. So our objectives for today, by the end of the lesson, I will be able to estimate using rounding, estimate using front-end estimation, and estimate using compatible numbers. Right, so the first thing that we're going to go over is vocabulary. So you'll notice that in your workbook, you have a vocabulary section. Then you have a word, the definition, and then you have a space to put in an example. I try to keep these in order as best I can. Sometimes some of the words get a little bit out of order. Just make sure that if you can't find it, pause the video, look for it, and then once you find it, resume the video. When you're doing this, you should be filling in the missing words and making sure to write down the example that I write down. This vocabulary is to help you when you're confused about what a word means or what we're looking for. You can always look back on this vocabulary and try to make sense of what you're doing. All right, so our first word is sum. The definition of the word sum is the solution or answer to an addition problem. Now, a lot of people think that when they see a plus sign, that means sum. This plus sign tells you that you're looking for the sum. It doesn't mean sum. This is an addition sign or a plus sign, not a sum sign. There's no such thing. So for an example, if I did 4 plus 6 equals 10, 10 would be my sum. So this should be written in your example box, and you should have the 10 circled because the 10 is actually the sum. This is the problem, this is the sum. Okay. Again, if we go a little too fast, you can also pause the video, make sure that you get everything written down, and then resume the video when you're ready. Add-ins. Add-ins are any group of numbers or digits added together to form a sum. So in this case, if you do 4 plus 6 equals 10 again, the add-ins are the 6 and the 4. Okay, and you also know that they're add-ins because it has the word add in it. So when you're adding, the numbers that you're adding together are called the add-ins. The difference. The difference is the solution or answer to a subtraction problem. So whenever you see a subtraction sign, you know that you are looking for the difference. Again, this doesn't mean difference. That tells you that you're looking for the difference. So if I use 10 minus 4 equals 6, the difference is 6. Product. Product is the solution or answer to a multiplication problem. Now, when we talk about multiplication, I know we all like to use an X as our multiplication sign. Starting now, we are not going to be able to use an X because when we talk about variables, we often use X as a variable. So we need to make sure to use our dot and asterisks, or you can use parentheses. We'll talk more about this when we get into variables. So right now, you can either use the dot or the asterisk. Right, so for example, if I do 4 times 6, that equals 24. 24 is my product. So 24 is the product of 4 and 6. And last but not least, quotient. Quotient is the solution or answer to a division problem. So typically you see the division signs like this or this. Again, these don't mean quotient. So if I take 24 and I divide it by 6, the quotient is 4. Okay, so one of the key things to remember is that for all but the word add-ins, all these are the answers to the problem. It's not the whole problem, it's not the symbol, it's not the act of the operation, it is the solution to the expression that is the quotient or the product or the sum or the difference. Right, so what does it mean to round a number? When we round a number, we're actually finding ways to make it easier to use the numbers. So when we round means to change a number to a more convenient or easy to use value. Okay, so both rounding and compatible numbers are forms of estimation. I know it seems weird because we always talk about rounding numbers, but you have to remember rounding is a type of estimation. So compatible numbers is also a type of estimation. So for rounding, we change a number to a more convenient or easy to use value. For example, instead of using 153, we can round this to 150. Compatible numbers. Compatible numbers are numbers that are easy to compute mentally. Okay. To make this make a little bit more sense, they're numbers that work well together, like friends. So you and your friends are compatible. You like the same things, you like to hang out. Because you like the same things, you are compatible. These numbers work well together, so they are compatible. When you use them together, they don't leave a remainder or they don't make it difficult to multiply. So for example, 30 and 5 would be compatible because you can easily multiply them, and 30 is divisible by 5. 40 and 8 are not compatible. Are compatible because you can divide 40 by 8 and get 5. And you can easily multiply them together. Front-end estimation. This is probably one of the most difficult types of estimation. You will only use this when you're working with decimals. So front-end estimation is a form of rounding used only for decimals, where we round the whole number and the decimal. So what you're doing is you're taking one number and you're splitting it into two different rounding pieces. So for example, I take 1 and 35 hundredths. The 1 would stay as a 1, and the 35 hundredths rounds to 50 hundredths. Okay, so then my front end estimation here would be 1 and 50 hundredths. This is the type of estimation that I think we're going to struggle the most with, so make sure to take your time and go back and re-listen to the lesson if you're still struggling. Okay, when we estimate the sum by rounding to the thousands, we have to look at what we're actually doing. So in this case, the number that's in the thousands place is the 5. So we know that the smallest that our number can be, because this number 5,667 is between 5,000 and 6,000. So then we have to decide, halfway between 5,000 and 6,000 is 5,500. Is this more than halfway between the two numbers, or is this less than halfway between the two numbers? Because it's more, we round this number up to 6,000 because it's closer to 6,000 than it is to 5,000. Same thing over here. We have 2,000, so the lowest it can be is 2,000, and the highest it can be is 3,000. In between, we have 2,500. And because it is less than 2,500, it's actually closer to 2,000, so we round it to 2,000. So our estimated sum, because that's what we're estimating, so we round our add-ins first, is 8,000. It's not an exact answer, it's an estimated answer. Okay, so we'll try a couple, and I'm going to show you a method that I really like to use when it comes to rounding. It makes rounding a little bit easier. It's the dot and box method. So here we're going to round to the tens place. So in this case, I put a dot underneath the number that's in the tens place, so this would go under the 5. Everything else to the right goes inside the box. So the dot goes under the 3, the 1 goes in the box. The first number inside the box tells the first number outside of the box what to do. If it's 5 or above, you round up. If it's 4 or below, the number stays the same. You end up rounding the number down. And I'll show you what we mean by that, because the number doesn't actually drop down. The number stays the same, but the ones digit goes down. So in this case, the 7 is bigger than 5, so we are going to bump up the 5 to a 6, and we round the 57 to a 60. Now in this case, 1 is less than 5, so the 1 tells the 3 to round down. Now the reason it's rounding down is because 31 is changing to 30. The number got smaller. The 3 stayed the same, but the whole number itself got smaller. So our estimated difference is 30. Right, so I'm going to give you an opportunity to try these on your own. The first thing that you need to do, so here in your notes, you should have already followed along here. Here in your notes, you should be writing in what we've done. So here you would write down that we rounded to the tens and show the dot and box method. This became a 60. This became a 30. And then the answer was 30. So now here I'm going to make these available to you, and I want you to write in the place that you're rounding to. And then once I'm done, you can pause, and I want you to try the problems on your own. And when you come back, we'll check your answers. All right, so you're going to round to the tens, the hundreds, the thousands, and to the ones place. So make sure to pause, and when you come back, we'll check those answers. All right, so for the first one, we rounded to the tens. I'm going to go through it with you. The 19, the 9 told the 1 to round up, so it became a 20. The 42, because we're rounding to the tens, the 2 is less than 5, so it told the 4 to stay the same. It's a 40. And 68, the 8 is bigger than 5, so the 8 tells the 6 to go up to a 70, so our estimated sum is 130. Okay, to save some time here, you can take a look, you can pause and look over your answers. And the majority of the time, the biggest problem is that we rounded to the wrong place value. So you have to make sure you know where your place values are. So go through, check to make sure you have the correct answer. If you didn't, pause, check my work to yours, fix it, and then if you're still confused or if you have a question on it, make sure to maybe star the problem or write something down in your workbook so you can type me a question out in Modo, or you can ask tomorrow in class. All right, so now we're going to talk about compatible numbers. Remember, compatible numbers, we said, are numbers that work well together. So in this case, 5 and 37 do not work well together. Yes, we can multiply them. However, we can make this a little easier to do in our heads by making the numbers compatible. So what this means is, instead of using 37, I would actually use 40 because it's easier to multiply. Any number that ends in a 0 is easier to multiply with. And because 37 isn't that far away from 40, it gives us a general idea of what the answer to this problem is going to be. Okay, you have to remember, in this case, we're overestimating because we made the number bigger than the original number. So you want to use overestimating, especially when you're talking about things like parties and who you're inviting and how much food to buy and things of that nature. You typically want to stay away from underestimating unless you're specifically trying to make sure that you have less of something than you need. Okay, so in this case, my estimated answer would have been 200. So what I want you to do first I want you to check to see, or is to try to make compatible numbers. Pause the video. When you come back, we'll check your compatible numbers and then we'll go over the products. All right, so now that you're back, we found that we would change the 16 to a 15. Okay, makes sense. We're going down, and 3 times 15 is easy to do, especially if you think of a clock. And 8 times 39, we would change to 8 times 40 because it has a 0 at the end, which makes it easier to multiply. So now I want you to try and compute these mentally in your head. When you come back, we'll check your answers. So you should have gotten, when you did these, 45 and 320. Remember, when we multiply with digits that have, or numbers that have a 0 in the ones digit, or in the ones place, all you have to do, you take the 8 times the 4, which is 32, and then because you have a 0 at the end and there's only 1, you add 1 0 to your answer. If there were 2 zeros here, we would add 2 zeros to our answer. It makes multiplication very easy to do in your head. All right, so one of the examples that I'm going to do with you is a word problem. When we do word problems, I want you to have a highlighter so you can highlight the important information. So first, read the problem. Mrs. Higgins is planning a party for the whole 6th grade. There are 17 students in each STAR class, and there are 9 STAR classes. About how many students should she plan for? All right, so is it important that Mrs. Higgins is planning a party for the whole 6th grade? Not for our purposes. Okay, that's just kind of fluff information to let you know what's going on. Is it important to know that there's 17 students in each STAR class? Yes, it is. And it's important to know that there are 9 STAR classes. Those two numbers are going to tell us what numbers we need to use and what we're going to work with. The other important thing is the question about how many students should she plan for. One of the most important parts of that sentence is the word about. Anytime you see about, you know that you have to estimate. You are not looking for a perfect answer here. You are looking for an estimation. So I know that there's 17 classes, and I know that there's 9 students per class. And I know that if I want to figure out how much food I need to buy, I would do 17 times 9. Well, that's not a really nice problem to do in my head. And what I'd like to do is I'd like to make it easy to do in my head so it's easier to purchase things at the store. So what I can do here is I can change this, and I can change this to keep the 17, and I would change the 9 to a 10 to make these numbers compatible. Now, I know some people would say, well, you could change the 17 to a 20, but because I would change this number by 3, and I only change this number by 1, I want to use the one where I change the number the least. That's going to get me closer to my real answer than changing the number by 3. So in this case, I would plan for 170 students. Okay, so here what I want you to do is I want you to find the numbers that would be compatible with each other, but now we're working with quotients. It's the same idea as with multiplication, except for now we're just using division. So in this case, it would be, we would keep the 100, and we change the 52 to a 50, because we know easily we can do 100 divided by 50 is 2. I want you to look at the rest of these problems, and I want you to try them on your own. You have to know your times tables though, so make sure that you're paying attention and you're using what you know about multiplication to pick the right numbers. Go ahead and pause your video, and when you come back, we'll go over your answers. All right, so for this one, you should have changed the 9 to a 10. Okay, because if you change the 20 to an 18, you're moving your number too far. You want to change the number that has the least change. Okay, so in this case, changing this by 1 was better than changing the 20 by 2. 60 divided by 23, we would change to 60 divided by 20. And here, I know a lot of people probably changed this 8 to a 5, but if you know your times tables, you know that 64 is compatible with 8. So we change the 65 to a 64 and get 64 divided by 8 equals 8. This form of estimation can be a little bit difficult. You just need to practice with it and really practice your multiplication tables. If you have your multiplication tables memorized very well, it makes compatible numbers a lot easier to work with division. All right, front-end estimation. Now, we should be about here in our notes. I really need you to follow along and put the pieces in the correct place. and really make sure to go slow and write everything down that I write down. You can always pause, rewind, go back. Take your time on this. This is a little bit confusing. All right, so when we use front-end estimation, the first thing we do is we just add the first number of each number, so the first whole number. So in this case, we would use the 9, the 22, and the 8. So in your boxes back here, you would write down that you're using the 9, the 22, and the 8. Okay, and I tried to make this so that way you have the kind of the connecting pieces here. So make sure that you are using this and using this as a reference if you're getting confused. Now in this case, now what we're going to do is we're going to round the decimal part. So now we're done with the whole number. Now we're just looking at the decimal. So we're ignoring the 9. I just changed it to a 0 to make it easier. So I have to decide, is it closer to 1, 50 hundredths, or 0? My cutoff points in this case would be 25 hundredths, because that's halfway between 0 and 50, and 75 hundredths, because that's halfway between 50 hundredths and 1. Okay, so if we land directly on this, we always round it up. So 18 hundredths falls right here, so we are actually going to round that down to 0. 89 hundredths is bigger than 75 hundredths. Okay, it's actually up here, so we're going to round that up to 1 because it's closer to 1 than it is to 50 hundredths or to 0. And 30 hundredths, because it falls in here, it's closer to 50 hundredths, so we're going to round it to 50 hundredths. Now what we're going to do is we're going to take those 3 decimal numbers and we're going to add them together. So we're going to take 0 plus 1 plus 50 hundredths, and we get 1 and 50 hundredths. Now we have to take our added sums, and I apologize, I forgot to add this up here. So 9 plus 22 plus 8 gives us 39. So now we're going to take that 39 and we're going to add the decimal to it. So we're going to take the whole number sum that we got, the decimal sum that we got, and we're going to add them together. They give us 40 and 50 hundredths. And that is our front-end estimation. All right, so what I would like you to do now is I would like you to try this problem on your own. All right, and when you come back, we will go over your answer. All right, so in this case, what you would have done is you would have added your whole numbers, so the 7, the 36, and the 5. And when you add those numbers together, you get 48. Then you would estimate your decimals, so the 86 hundredths would have went to 1, the 97 hundredths went to 1, and the 40 hundredths went to 50 hundredths. Then you would have added those decimal pieces together. Then you would add the 48 that you got as your whole number, plus your 2 and 50 hundredths as your decimal, and you would get 50 and 50 hundredths. Again, if you struggled with this, pause, look at my work, compare it to yours, and it's okay. We will do some of this in class tomorrow. Like I said, I know this is going to be difficult for you, so take your time on it. All right, the last thing that I would like you to do, you need to go onto Edmodo and you need to post an answer to each of these questions. So when you post to Edmodo, you need to make sure that you're posting and you're saying, okay, 1, what estimation technique would be best for division? And then type whatever your answer is. If it's rounding, compatible numbers, front-end estimation, okay? And then 2, and type your answer all in one post, all in one reply to my post. Also, in this spot, it'd be good to ask any questions that you might have so we can go over them right away in class tomorrow. So please make sure to post your answers to these questions, and I will see you in class tomorrow.